Morning, children. Today we'll start a new chapter, second chapter, Elements of Chemistry. And in this chapter we'll learn the matter. Now, definitions of this matter. Anything that occupies space and has mass is called matter. Now, matter is divided into two categories: pure substance and mixture. What is pure substance? A pure substance is one that contains only one kind of particles. It may be atoms or molecules. Now, these pure substances are further classified into two main categories. One is element, another is compound. Two or more pure substances mix together to form a mixture. Now, mixture is not a pure substance, it is an impure substance. Element. Now, element is the simplest pure substance that cannot be broken into two or more simpler substances by any physical or chemical methods. That means the element contains only one type of particles. It is the simplest, it is the pure substance and contains only one types of substances. Examples of elements are hydrogen, oxygen, nitrogen, etc. The smallest particle of an element is the atom. So what is the definitions of atom? The smallest particle of element. Now, atom has no independent existence. Atom can't exist freely. It will exist only in combined state. An atom exhibits all the properties of the elements since it is the smallest particle of that element. An element is made up of only one kind of atoms. Since elements are the pure substances, there is no chances for mixings of anything other than that particular substances, and that's why the elements contain only one type of atoms. For example, iron is made up of only one type of atoms, that is iron atoms. Similarly, copper made up of only one type of atoms known as copper atoms. The atoms of one element differ from atoms of other element. Definitely, because the properties of the elements are different for different cases. That's why the properties of the atoms are different from one element to other element. Thus, each element has its unique properties. Now, for example, that all the atoms of iron has that magnetic properties, but the atoms of sodium don't have any magnetic properties. They will not be attracted towards magnet. Thus, each element has its unique properties. Atoms of oxygen are identical and all atoms of nitrogen are identical. But the atoms of oxygen are different from the atoms of nitrogen, because atoms of oxygen is the smallest particle of element oxygen. It is the smallest particle of element nitrogen. Till today, 118 elements are known, and these elements are arranged in a periodic table, and they are arranged as per their atomic number. In higher class you will learn about atomic number. This is a periodic table. Now, first element hydrogen, second helium. These are the symbol, simple representations of the element. First one, hydrogen. Second one, helium. Third, lithium. Fourth, beryllium. Fifth, boron. Sixth, carbon. Seventh, nitrogen. Eight, oxygen. Nine, fluorine. Neon. Tenth element. 11, sodium. Magnesium. 12th element. 13, aluminium. 14, silicon. 15, phosphorus. 16, sulfur. 17, chlorine. 18, argon. Next, 19, potassium. Calcium. These are the first 20 elements. Rest are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, bromine, krypton, and all are these. Now this first, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, these are known as alkali metals. Beryllium, magnesium, calcium, strontium, barium, radium, they are collectively called as alkaline earth metal. Helium, neon, argon, krypton, xenon, radon, oganesson, these are collectively called as inert gases. Fluorine, chlorine, bromine, iodine, they are collectively called as halogens. So these are the simple format of this periodic table. Out of these elements, some are found in nature while others have been made artificially, the man-made. Okay. Copper, silver, gold, platinum, carbons are found in free state in nature. Iron, sodium, magnesium, they are the highly reactive. That's why they are always found in the nature in the combined state, as they are very reactive. Now oxygen is the most abundant element present in the earth's crust, followed by silicon, aluminum, iron, calcium. So oxygen, silicon, aluminum, iron, calcium, these 5 elements account for 91% of earth crust. Now among 118 elements, few are solids, some are liquids, and some are gases. There are 2 liquids. One is mercury. Look at this 80 number. 8G is the mercury. Bromine is also the liquid in state. 35, bromine. Few are the gases. Hydrogen, for example, hydrogen is the gas. Helium, oxygen is the gas. Nitrogen gas, neon gas, etc. And rest are the solids. Copper, lead, magnesium, calcium, silver, gold, iron, sulfur, zinc exist as solid. These examples are the examples of the metal. Mercury, bromine exist as liquid. Hydrogen, oxygen, nitrogen, and etc. are exist as the gases. Now on the basis of the physical and chemical properties, elements can further be broadly classified into metals, non-metals. Metals are hard, have shiny appearance, and form alloys. Alloy means the mixtures of metals. In the first chapter we have discussed about these things. The alloy, the mixture of metals, is known as alloy. Generally metals are solid. Exceptions is mercury. Mercury, though it is metal, but exists in a liquid state at room temperature. Copper, silver, gold, platinum, iron are some examples of the metal. Now non-metals are dull, soft, generally liquids or gases at room temperature. Now carbon, sulfur, oxygen, hydrogen, these are the non-metals. Another types of elements are present. Some elements such as silicon and antimony, so some properties of metals and some properties of non-metals, and thus they are called metalloids. Now metalloids shows the few properties for metal and few properties for non-metals. Helium, neon, argon, krypton, xenon, radon are gases and they do not take part in any chemical reactions. Hence, they are called inert gases or noble gases. So children, today we have learned that elements, atom, compounds, mixture, metals, non-metals, periodic table, metalloids, inert gases,